Stangibelisco here, showing you a generic diagram of an amplifier circuit that happens to be Class A using an NPN bipolar transistor. R2 and R3 determine the base bias, which in this case is set for Class A. We could change these values and get anywhere from Class B by getting rid of R3 altogether to something more close to saturation than Class A, which is practically never done. But that's the extent of the range that we can obtain with fixed resistors like this and a ground here. But I have an idea for a more flexible type of amplifier. Imagine that we put a sine wave audio tone of 500 Hertz here, an oscilloscope here at the output. Then we're going to see a 500 Hertz sine wave on the oscilloscope, assuming this is Class A. And that's it. We're stuck. We're fixed. However, we can also make the system more flexible by placing a potentiometer right here, minus 12 volts here, that's minus 12 volts with respect to ground, and plus 12 volts up here, again plus 12 volts with respect to ground. Then we can adjust this potentiometer anywhere from minus 12 volts, which will give us Class C plus. It'll go way past cutoff, to the middle, which would give us Class B, assuming this is a linear taper potentiometer, to near the top, which would give us Class A, and then all the way to the top, which would produce a saturated state in the transistor and deprive the circuit of amplification altogether. So we can get Class A up here, Class B around here in the middle, and Class C down below. If we go all the way one way or the other, we're either going to cut that thing off completely to the point where it'd take a stronger signal than you'd get out to get in, and all the way up here, which would be saturation, and you wouldn't get anything out at all. But what would be interesting to try would be to build an amplifier like this, put a 500 Hertz sine wave audio tone here, and an oscilloscope here, and watch the waveform on the oscilloscope as we adjust this potentiometer. A sine wave somewhere middle top for Class A, then the part of the sine wave would get flattened and cut off, then half of it would get cut off, then most of it would get cut off. That would be Class C, half of it getting cut off, Class B. Then Class AB1 and AB2 are a little much too detailed to go into right now, but that's where part of the waveform is cut off, but less than half, all the way up to Class A, and then something past Class A, which again, as I said, is almost never used. It'd be interesting to try that as an experiment. 500 Hertz sine wave audio tone here, and an oscilloscope here, and then slowly adjust this potentiometer throughout its range. I will not give specific values for these components, but I'd suggest maybe 4.7K or 10K for this potentiometer, 100 ohms for R1, 100 microfarads for C1, whatever you want for R sub 3 here or R sub 4 in the other circuit, the collector resistor, probably on the order of whatever the impedance of the oscilloscope is, uh, 1,000 ohms, something like that. Just enough to get some output. Try building this circuit and see what happens. Unfortunately, my lab is too uh, limited in equipment right now to do this experiment. But if somebody wants to try it and let me know what happened, I will leave comments open. And as for whether or not this video is perfectly polished or not, I would say not. And I would say, so what? And I would say, until next time, so long.